Strange stuff going on at the Cape. For some reason, almost immediately after the launch, the media was asked not to film the mobile launch tower, and NASA really didn't give any explanations as to why, and it hasn't even really been publicized very much that this was going on. And so, what the hell is going on? Is the launch tower damaged? I mean, I've never thought a whole lot of this thing. I've always felt that it's been a cobbled together piece of garbage constructed by three different contractors, so we can expect that it might have sustained some damage. But was it so bad that NASA doesn't want any cameras on it? Or is there another reason? And meanwhile, here in Cornwall, just about every barrier has been removed for the first ever launch from Western European soil. The only thing that remains is a wet dress rehearsal, and then it's time for launch. I have to admit, I'm getting pretty excited about this, but what am I really excited about? What sort of payload is this rocket carrying, and why does it matter? Hello, YouTube. I'm the Angry Astronaut coming to you from Spaceport Cornwall, standing right in front of Cosmic Girl and Launcher 1. And this is Okay, guys, I know that you can't wait to hear what's going on over at NASA, and I certainly don't blame you. However, I'd like to get to what's happening at Spaceport Cornwall as well, and what's going to be going up on this rocket in just a few days. But nevertheless, if you absolutely can't stand this stuff, you can skip to here, and that's where my NASA coverage will begin. But I think you're missing out if you make that decision, but it's up to you. Let's get on with it. All right, guys, we are here again at Spaceport Cornwall, and we're going to be learning a lot about satellite integration and what's going to be happening here. Sir, would you be so kind as to introduce yourself to the viewers?
Yeah, so I'm Tim Pinchin, and I'm head of communications at the Satellite Applications Casbolt.
So tell me about your role here. I mean, there seems to be lots of companies involved in the deployment of a single satellite. So you tell me a little bit about what your company does as far as, this process is concerned.
So we're an innovation and technology company, and our role is to help grow the UK space sector. We were set up and part funded by Innovate UK, and our role is that growth of the space sector. And so we get involved at all stages in order to support businesses to grow and to do things, difficult things like launching a satellite into space. We help to remove those barriers that make that difficult, and make them happen more quickly than if we weren't there.
So kind of implementation, right? Is that kind of the best way to describe it?
Yeah, I mean, we support and help in a whole load of different ways, actually. So we provide things like facilities for organizations to come and use. So we have testing facilities, things like clean rooms and vibration tables, which simulate what happens when a rocket launches. But then we also help with the business side of things. So we will work with businesses to help them understand what their business model is and how they launch it. And then for things like our in-orbit demonstration program, which this satellite is a part of, and I can talk to you a bit more about that in a minute, we've found organizations across the UK who have a really great idea for a satellite service, a data service that runs off a satellite. And we help them bring it to fruition. So we've helped with planning operations for this mission. We've helped with sourcing the satellite. We've helped with figuring out how it's going to work, how the data is going to come down, and other things like that, to just make this happen more quickly and make something that's really difficult a reality for a UK-based company.
So tell me, obviously, you've got the customer here, and then who else is your company working with for the implementation and deployment of satellites?
Well, I think this satellite is just a remarkable UK success story. The whole ecosystem for small satellite manufacture and build across the UK is just absolutely brilliant. So the satellite is supplied by AAC Clyde Space, who are on the banks of the River Clyde in Glasgow. And two of their engineers are here today unpacking the satellite and doing all of the checks. And so it's been a great collaboration with them, but also a whole host of other companies. So we have companies in Scotland called Bright Ascension. Um, we have a data company called LN Systems who are in Lincoln, who are working with Horizon Technologies to understand the data that's coming down from the satellite. Horizon Technologies themselves, it's their constellation, it's their satellite. They're going to be taking the data from this satellite as the first of 20 satellites they're going to put in this constellation, and that's supporting a business model for them. And then down here in Cornwall, which is where we are today, we've got obviously Spaceport Cornwall, who are this real cluster now, this real hub for space businesses, and Goon Hilly Earth Station. And Goon Hilly Earth Station's helping run mission operations for this satellite. And so it's truly a supply chain and an ecosystem across the whole of the UK.
Exciting. Is your company launch provider agnostic? That is to say, could we expect you guys to launch maybe with Skyrora out of Saxavord or something in the future? Is it going to be Virgin Orbit?
Yeah, I mean, all of those requirements are always driven by the customer and by the commercial need. So this is the third satellite in the IOD program. We've launched other satellites from other places around the world, wherever commercially we can ensure that we get a good agreement for our customers. But absolutely, I mean, in the future, having this launch capability in different formats across the UK, able to access different orbits, it's such a game changer for the industry. So yes, 100%.
So obviously this is, at least in my opinion, the biggest mission you guys have ever had. I mean, you guys sell your services as in we can launch from anywhere, as long as you have these kinds of facilities in place, you don't have to send your satellites to the US, you can launch them from your own country. And so it's really important that you don't have an anomaly here. How does this make you feel, and what sort of steps have you taken to make sure that this mission goes off without a hitch?
So, this is definitely a monumental mission for us. I think that the system in and of itself was inherently designed to be that mobile, anytime, anywhere type of unwarmed capability that you can just pick and place anywhere and conduct an operation. We have an amazing set of engineers who are diligently going through the entire rocket from design through operation, from design to test to operation. This will now be the fifth successful launch that we'll, fingers crossed, that we'll be launching. But I'm confident that we have a great team here that has not only the experience to go through the operation, but also ensuring that we're doing things right, so that we have a successful launch.
One more real quick question.
Okay.
I've heard some rumors about some thoughts or maybe beginning plans of manufacturing launcher ones in this country. How do you feel about that?
Well, I can't speak to that.
Now, you'll forgive me while I read entirely too much into what Mr. Hernandez had to say. He didn't say, oh, I haven't heard anything about that, or to my knowledge, nothing is going on, or that if there was something going on, I wouldn't be opposed to that. That sounds like a pretty good idea. Instead, he immediately responded, I can't speak to that. That's the kind of response you get from somebody who has been legally barred from saying anything about a subject, which means, in my opinion, there are ongoing negotiations that Mr. Hernandez can't talk about. Let's get back to our interview with Catapult. I've got two more questions for you, and they are interrelated. First of all, many people would make the argument that we have so many satellites up there as it is. We already have lots of collision avoidance issues. Plus, not only that, putting these things up creates greenhouse gas problems. What is somebody who's planning to send up lots of satellites? What's your response to that?
Well, an awful lot of the satellites that are put up nowadays have a fantastic credentials in terms of the actual services, the data services that they provide. And what I mean by that is, at the moment, more than 50% of essential climate variables are either exclusively or best measured from space. And I know it's sort of a slightly strange answer to the question, but there's always got to be weighing off against these different elements. So we use this climate data to inform and educate people and to monitor what's going on with things like ocean temperature and the amount of CO2 in the atmosphere and things like that. And we've got to be able to see that in order to take some action against it. And I mean, and you know, there are other fantastic examples of where broadband internet, which is provided from space, is able to support learning, you know, support educational environments or support remote healthcare. And so I think for me, the balance has always got to be doing something good with the satellite that you're launching. And then here at Spaceport Cornwall, you know, their whole remit is about launch for good and how this can be the most environmentally sustainable launch in the world.
So the last question in regards, again, connected, as I said, to the previous question, you know, we've recently added, you know, regulations to deorbit satellites within 5 years of deployment, that sort of thing. However, there are, you know, circumstances where a satellite either malfunctions or gets hit by debris and such, and therefore cannot deorbit itself and becomes essentially an unguided missile out in space. The more satellites we launch, the greater the problem becomes. Is Catapult engaged in any sort of projects right now to actively clean up space, you know, help deorbit these things?
Yeah, absolutely. Well, I'll mention another Catapult partner, and we've been working with Astroscale, who have a huge base in the UK now. They've just launched a new satellite manufacturing facility in Harwell, in Oxfordshire, but they are working towards deorbiting satellites by coming together with them in space, and then doing a powered deorbiting of these satellites. So, you know, the intention is obviously that every satellite that comes up comes back down in a safe way.
Fantastic. Yes, I've done, as my viewers know, I've done a number of videos about Astroscale. It's really exciting to hear that you have that collaboration. Is there anything else you'd like the world to know about what you're doing?
I think I'm just so excited about the fact that everything has come together in the UK for this first launch. So the ecosystem has just been amazing in offering everything that is needed to put satellites into space from the UK. And I just think it's just the start of that next great step forward for the UK space industry.
Well, I'm very excited about it as well. Once again, thank you so much for your time. Hey guys, for those of you who skipped to this point, I am very sorry, but I just wanted to make two real quick points to you about this entire mission that I want everybody to know. First of all, if things go off well, we're looking at the possibility of manufacturing new Launcher 1 rockets in the United Kingdom, making this a truly international partnership. And also what you're watching right now is a future interplanetary mission that Virgin Orbit has planned through a consortium of Polish universities and companies, and I have very little doubt that a Polish consortium is going to want to launch out of Cornwall and not out of the United States. Big things coming to Spaceport Cornwall. Let's move on. So since I started recording this video, a lot more is actually developed in this whole launch tower situation, and NASA forbidding photographers from taking any high-resolution shots of it. There are quite a few remote cameras, or at least there were, in the immediate vicinity of the launch tower. Now, there was also a great deal of hazardous gases escaping from damage in the launch tower that prevented anybody except essential personnel from approaching their equipment, including all of the cameras. Now, there would have been nothing preventing a number of these people from taking photographs while they were waiting to get their equipment. However, NASA requested that they not do so. As a matter of fact, they absolutely forbade them from doing anything like that. So, of course, this has triggered a great deal of speculation. What might have happened to the launch tower, and what is NASA really concerned about? Well, Eric Berger at Ars Technica speculated that there may be a lot more damage than what NASA was anticipating, and they didn't really want to make that public just yet until they had an opportunity to assess all the damage and then release the information about it. But it's also possible that this is just standard operating procedure in a post-launch protocol, because once the rocket takes off, there are ITAR restrictions on certain types of technology that might be revealed to the naked eye that wouldn't have been apparent when the rocket was actually sitting on the pad, and actually any damage to the launch tower could also reveal some of this technology to the outside world, and NASA doesn't want that to happen, and ITAR restrictions allow them to prevent photographers from actually taking any pictures. But it still was extremely odd that this request was made immediately after the launch, and all in block capitals to all of the photographers. It was a strangely urgent request, or demand actually, being made immediately after the launch as opposed to something that may have been planned before the launch. Chris Davenport from the Washington Post was also curious about what was going on and received the following statement from NASA, quote, "Teams still are in safing operations at the pad and it remains a controlled area. At this time, only essential personnel are permitted to enter the pad perimeter. Media is expected to be able to retrieve their cameras tomorrow morning. Because of current state of the configuration, there are ITAR restrictions and photos are not permitted at this time. There also is launch debris around the pad as anticipated, and the team is currently assessing. I asked them to provide you with more info on the ITAR situation. The umbilical plates are exposed, and high-res shots of those would be an ITAR violation." And here's another rather disturbing detail. The SLS rocket seemed to have lost some pieces while it was taking off with the Artemis 1 mission. Now that of course could be very problematic, but NASA spokespeople said it wouldn't have any effect on the spacecraft. But pieces coming off of the SLS is certainly something that they couldn't have anticipated. Nobody wants chunks coming off of their rocket while it's launching. And I believe there may be some question as to whether or not the debris that was coming off of the rocket may have actually been debris coming off of the launch tower during the takeoff. These are details that we still don't have a great deal of information on. Hopefully we will get more information as time goes on, but it certainly appears that more damage was done at the launch pad than was anticipated. In my opinion, the damage was so severe that the moment that NASA saw what had happened, they also recognized that there were some sensitive areas that had been uncovered as a result of the damage, and then they had to hurriedly tell all of the photographers to stop taking footage. So in any event, we're hopefully going to find out more details about this, but I believe that based on everything we know about ML1, there's a lot of reason to believe that this takeoff would have created far more damage than anticipated, simply because NASA doesn't know enough about the launch tower to really make an educated guess as to how bad the damage might be. And just to give you a quick idea of why I hate ML1 so much, and I think it's such a problem-ridden ground system, I'll refer you to a quote from the NASA OIG report about the launch tower. Quote, "NASA's acquisition strategy for ML1 did not provide for effective coordination among the various design activities and failed to initially identify a design contractor that specialized in large, complex construction projects." In other words, they didn't even have a contractor who specialized in building things like this in the first place. They go on to say, quote, "Although design errors are to be expected in a project of this size and complexity, the amount and associated cost for design modifications for ML1 could have been reduced. In addition, immature or undefined SLS and Orion requirements also caused numerous design changes. The ML1 project experienced numerous design errors during the outfitting of the tower that resulted in cabling and structure structural design conflicts, equipment that did not work as intended, and issues with the fabrication of the umbilicals. NASA exacerbated these issues by accepting unproven and untested designs from Vencor in order to advance the construction and fabrication contracts. Agency personnel stated that at times they knew the subsystem designs were not complete or needed more testing, but advanced them because the project schedule required it, so fabrication and construction activities could continue. There are so many things that could potentially be wrong with ML1, and I'm pretty certain that anything wrong with the structural design was blown to bits during the takeoff. Now, I have every confidence that NASA can repair the launch tower in the vast amount of time available to them until Artemis 2, but here's another problem. As I've said many times, this launch tower was constructed by 3 different contractors who really didn't communicate with one another. So does NASA really know how to fix everything? That could be a bit of a problem as well, and could delay the process, given that nobody has a complete, comprehensive understanding of how this thing works. But before we come to any alarmist conclusions about all of this, we really need to consider something else as well, and I'm going to paraphrase an article that I recently read about launch pad problems. Quote, "The post-launch inspection team heads out to the launch pad to instantly appraise damage at the pad and look for debris. They look over every part of the launch complex, despite the fresh layer of exhaust residue left by the solid rocket boosters. You see a lot of scorched metal, some bent," said Jeff Painter, who has seen launch pads after liftoffs for more than 20 years. Because the elevators are not working after launch, the engineers have to take the stairs all the way up the fixed service structure. "There's definitely a chemical metallic smell," said Tom Carlton, who's been on the inspection team for 2 years. "Looking over the launch pad used to be akin to developing a catalog for destruction. Melted speakers would wrap around poles or columns in the launch tower, drink containers tucked away and forgotten would be jarred loose and strewn about, and a few tools, such as wire brushes, would be found on the launch pad or in the blast zone. Each of the engineers knows a specific area of the launch pad and evaluates that area closely during the inspection. When it's finished, they can offer a conclusive report as to what items broke loose, what should be replaced or moved to a different part of the pad, and what damage parts of the pad incurred, such as the hold-down posts that connect the boosters to the launch platform. This, of course, is not a description of a post-SLS launch, but rather a post-space shuttle launch. In particular, the STS-127 launch of Space Shuttle Endeavour, after NASA had lots and lots of time to get very good at making sure that their launch pads did not get damaged during shuttle launches. They were still finding unexpected damage even then. So really, if there is an extensive amount of unexpected damage here, we should not be terribly surprised. Even if ML1 was in perfect shape and extremely well designed, it probably would have suffered more damage to various components than was expected, simply because nothing this powerful has ever taken off on a NASA pad before. That doesn't mean that we should give them a passing grade because of this. If ML1 is very severely damaged and NASA is not entirely certain as to how to fix it and bring it back up to code again, they need to scrap the damn thing and move on to ML2. However, after having thought about this and examined it for a couple of days, it's my conclusion that NASA probably can get ML1 working well enough, at least for a couple more launches, until Artemis 4, when they're ready to replace the entire system with a better rocket, or perhaps even Starship and Mobile Launch Tower 2, or whatever ends up launching Starship if it's advanced that far. It's my sincere hope that they find a better solution than what they had on the first launch of the Artemis program. Also, please remember, we are now currently at 89,763 subscribers. We're so close to 90,000 I can taste it, and almost on the home stretch. So, please subscribe. Please check the description for various ways to support this content and to become part of our growing Discord community. Please like this video and, as always, stay angry about space!